Bill, thanks, Ron. Yes, I'm Zach Crowder, Director of AI Innovation here at Trellix. And if you're not familiar with Trellix, we are the merger of FireEye and McAfee Enterprise. So we merged about 4 years ago. So we're a cybersecurity company, but we'll dive in of how we're leveraging services like AWS Bedrock and agents to really accelerate innovation in our products, but also engineering. And you'll see in a minute, like how that relates to the whole content generation with the agents. Um, So just some background, right? So our original approach when the two companies came together is, we had a deep history of doing machine learning, like over a decade. And, our process internally was, we have connectors connecting to thousands of different data sources, ingesting large amounts of data that our threat researchers, they look at on a daily basis, right? Here's data coming in from our endpoint solutions like telemetry, but also open source information. How do they decipher, noise out of that and find signals of like here's emerging threats or threat actors that are emerging in the space that we need to start building content for. Now ML was great at this, being able to bubble up the very interesting artifacts to look at, but it still required a human to sift through those alerts and determine, hey, like here's everything that ML bubbled up, but these are false positives or benign. They spend a lot of time trying to comb through that and identify really where to start their process of building out content for our products. And so obviously, about 2.5 years ago, generative AI came out, right, kind of burst onto the scene. And we realized, this is a really great opportunity to help kind of streamline that whole process. So still have ML running, still ingesting large amounts of data into our data lake, but this is where we started really leaning in with AWS Bedrock. And now that we can have, Claude, for example, running, and we took the last 2 decades of knowledge from both companies of how to do threat hunting, threat research, incident response questions our researchers would ask on a normal basis about our data, and allow Bedrock and Claude specifically to be able to ask those questions and do its own research on all that data that's coming in to really identify the really important artifacts and bubble those up to the researchers, saving them time from having to comb through the large amounts of data and really trying to find, what's relevant, what's not relevant, what do they need to create content for, not create content for. And we really found this is a very efficient approach to really augment AI with our humans, right? So we're not replacing our researchers with this approach. We're augmenting them with this technology to make them more efficient. And so one of the reasons, we went with AWS Bedrock, if you're not leveraging it today, is it allowed us access to a plethora of different ML models that were, or, sorry, LLMs that were out there that we could test with. And it really allowed us to adopt a fail fast, learn fast mentality internally. Because as new models are coming up, we can test them against our existing use cases or ideas that we have to see if they're generating the right outcomes that we're expecting. But the fact that it gave us access to all these models, we didn't have to pay for, hosting. We could just spin up and connect to, Claude Sonnet or Mistral AI, at the flip of a switch within our code. Like it made it very efficient to be able to identify the right models for the right task at hand or the right use cases. And so that's really where it goes in this. So as we talk about LLMs, I know a lot of people, you probably go to all the leaderboards that are out there. And, usually it's Claude and Gemini, even Nova that are usually at the top of that, those leaderboards. But what we found is those leaderboards are very generic, right? It's very broad testing that they go through. So what we actually did is we actually built out our own internal testing framework to be able to continually test models as they're actually released on Bedrock to make sure we're picking the right models for the right use cases we have at hand, right? So since we're a cybersecurity company, one of the testing frameworks is how well can a model ingest, a raw alert from endpoint security solution, summarize that event, and then write up a recommendation or action an analyst should be able to take. We're even able to have a testing as well of, hey, you're taking all these indicators of compromise, so things like IP addresses, domains, even hashes, and how well does the AI correlate that to threat actors of building kind of a threat profile. Even to some more basic things of like how well can a model take a base64 encoded string, decode that string, and explain what occurred in that. So those are some use cases, and we have many more, but they're all wrapped around this testing framework. And as it's continually running against the models that are launched in Bedrock, it allows us to make sure we pick the right model for that right use case. Just an example, going back a little bit when, Claude 3.7 came out, we actually noticed that 3.7 was actually performing less efficiently than actually 3.5. But it's a very good indicator of instead of just jumping to the latest model that's coming out there, we decided to stick with 3.5 at that time because it was still more efficient than 3.7 in our testing, right, for doing event analysis and triage. So I highly recommend all y'all. We do have a blog out there on the AWS website of how we went through this process, but definitely build out your test use cases and test them against various different models because you're going to find some really excel in specific areas and they may excel in the area that you're looking for. Don't just always go to the Claude sonnets as an example. And so when we built this out, we really Wise is our AI platform. We started looking at like how can it help customers be more efficient in cybersecurity, right? So we built out a lot of new features within Wise of how can it do investigations across that data lake for our customers specifically of bulbing up the right alerts to how it can pull in threat intelligence to enrich threat alerts themselves and to give more relevance and context to particular events I was able to find, to even pulling in from third-party data sources even outside of the Trellix purview and really explain the big picture of what happened with particular events. Now, this was all originally driven straight to like Bedrock through like few shot prompting to be able to do this. But really, where things really change is really on the agentic AI front. I know it gets thrown out a lot. I know it's picked up a lot of steam this past year, but if you really look at how automations have gone through kind of the journey with large language models, it really started with the very traditional, right, which is usually backed by ML, right? It was more structured, predictable, event triggered, but it had limited flexibility and required a lot of manual adjustments and changes in the actual requirements itself. So an example would be like automated order confirmation emails or ensuring customer communication. That was kind of the foundation or kind of the first workflow that you kind of saw out there. Then really came out the AI enhanced workflows, right? Of very data driven. They can learn, they're adaptive to responses, intelligence decision, and really provides predictions and recommendations to really optimize outcomes. Example would be automated document processing, leveraging machine learning to extract and categorize critical data. But then where really things flipped on its side its head, right, is really agentic AI workflows, right? Now you have something that's autonomous in operation, it's proactive in how it adapts to the environment, outcome focused, has memory, can do strategic planning, can collaborate with other agents to be more efficient, and can do all this without human oversight. So once we realized this, like then we were able to expand on what we had, right? So now we have agents that run in our ecosystem that really run in the background, right? So a lot of those tasks that I talked about that researchers used to do, we're out now able to automate a lot of that within our product and solution to make it more beneficial for our end users and customers, right? So now when a threat alert comes in, our agents are able to pick that up and go, okay, I see this alert this came in. It looks like credential theft. But now I'm going to proactively reach out to the other agents that I have access to say, hey, based on the IOCs or indicator of compromise in this alert of these IP addresses, can you tell me, are there any threat actors that are currently taking advantage of these? But then you'd also ask even more questions, right? Of, hey, I know this customer has the Trellix endpoint detection response product deployed. I'm going to reach out to the EDR solution to do a proactive search across the ecosystem to tell me any assets that may be connected to this IP address. And also too, hey, I'm going to connect to our vulnerability management solution to tell me what assets have vulnerabilities that this particular IOC or threat actor is actually taking advantage of. And then it's able to correlate all that and build out a summary and recommendation of here's what I recommend the user to do. Or if you want me to be autonomous, I can actually go take action, knock those systems offline to protect the environment and write up which machines are knocked offline. And then you can go take action to bring them back to speed once they're clean. But the real beauty of this, it streamlines and automates all this. Whereas this typical workflow, a human or SOC analyst, in our case for cybersecurity, this whole process, maybe an hour, could be 3 hours or 4 hours for it to go through and ask all these different questions across different consoles, different API schemas, where now the agents are just working collaboratively to actually connect and build out the full picture and then take action on your behalf if you want to. That's the real power that agents are really bringing, right? So it provides, the instructions and guidance. So talking about those models that we built out and that, rich history of how to do threat hunting and threat research, all that's baked into the model. So they have over about 400 to 500 different questions they can actually use to guide them and to make sure they make the right decisions. It also helps us ground the agents as well, so they don't hallucinate or come up with, fake vulnerabilities or fake threats are out there. It grounds them to be able to answer questions we provided, and based on those questions, allow it to be able to take action in the environment like a normal user would or a normal SOC analyst would be able to do. Now, the other part of this too is as you're building out these agentic workflows, don't just stick with one model, right? So in this use case, originally when we launched Wise, like everything was powered by Claude because Claude is great from Anthropic. But we realized, a lot of times maybe Claude was more expensive to use and maybe a little bit slower. So what we've actually done in this workflow is we actually use AWS Nova Lite to once the event comes in, Nova Lite will review the event and those 400 different investigative questions we have, it'll pick out the right questions and build out a threat hunting plan. That agent will then hand over to the Claude threat hunter agent with that plan and actually proactively start searching the environment, pulling back the context, writing out summaries, recommendations, and determining if an event should be escalated to user or not. It's very efficient this way. There's a lot of cost savings as well by doing the multi-model approach because, like I said, Nova Lite is much faster and much cheaper, and Claude was much more thorough in doing an investigation. So pairing them together was an ideal solution for this. Now, all that was really based on, how we can do stuff in the products to make our customers more efficient, to be able to protect them from like a security operations standpoint. But once we saw this, we realized there's a lot of opportunities we can take advantage of for agentic AI internally in Trellix, right? And so one of the things that we built out about a year and a half ago now, we actually built out a platform called Sidekick to really augment our software engineers, our support staff, and even our consultants in their daily activity of what they're doing to generate content to make them more efficient and faster, right? And the reason we chose Sidekick as well is, if you talk to a lot of developers or just, other people, right? There's a lot of people that are skittish of leveraging AI tools because they feel like they'll be replaced by them. But the point of Sidekick was just really augment them to leverage it as a partner to go through the daily activity. So some of the superpowers of Sidekick that we had internally, right, is to build out applications to, how do we integrate with third-party applications of taking API documents from a third-party vendor, mapping that over to build out code internally, and then having our code be able to allow our product to connect to a third-party solution, to even be able to build out training exams to enable our own engineers to come up to speed on our own technology, but also provide content to our end users, right? Of, hey, we released a new feature or products. How are you able to get up to more speed faster? And so being able to build out those exams for the end users to even be able to do customer research. So pulling things from like the SEC database around like 10K reports and 8K reports about what's going on with the customer to help proactively guide our sales team of here's the right things you might want to talk about with this customer, to analyzing logs from our endpoint solutions, to even generate content for security, which I'll touch on here in a minute, and also building out integrations proactively for our API. Now, when we looked at all this, we started going down the path of, hey, we're gonna have to fine tune and train all these models to do all this. But before we do that, let's just step back and look at our current process today for generating a lot of this content. And so we really took it at the approach of if we onboard a user within Trellix today to do any of these tasks, like what is that workflow today? And we realized to develop a lot of our content, we already have that workflow for the human side, right? We onboard a new user, we give them documentation or reference architectures of, here's how to build out code or how to build out the exams. Here's what good code looks like. So as you're building code, here's how I can validate it, but here's also tools and applications that you can leverage to validate any tool or code you build aligns to the Trellix standards and guidelines and make sure there's no issues before you provide your customer. And once we realize that entire workflow, we realize we already have an agentic blueprint we can leverage. And so that's actually how we built out Sidekick is aligning to our human driven workflow. And so today, Sidekick is powered by this workflow that you see now is, we have a business analyst agent that's able to take the requirements coming from the user, whether to build out an exam or code, and then it breaks those down into smaller chunks and hands it off to the development team. And there's a senior developer and a junior developer that'll actually collaborate together to build out the application or the exam based on the requirements from the business analyst. They'll then pass it to our quality agent that'll then take code if they wrote that, run it against the tools and applications that we have to verify, there's no bugs or issues in the tool, but also verify it adheres to our internal standards. And then if it finds any issues, it'll pass that back to the developer agents to correct it or modify the code or exams and then provide the end result to the user. So it's very efficient in that process. And like I said, when we were going through this, we realized there was two buckets out of this process, right? We could fine tune a model, which, that can be very expensive, requires a lot of man hours to actually do that. But the other thing that we realized too is, we have a lot of data inside Trellix, much like you all probably do as well. But is that data clean or in a state we can actually use it to actually train a model on, right? And also it requires, a very specialized skill set to actually do the data training. Versus on the prompt tuning and just leveraging the prompt engineering within the agents, it's a much cheaper approach, pay by API usage, but is very easy to iterate with. And it was a skill that we could be able to train for new hires very easily instead of taking longer cycles, weeks or even months to train someone to be a data engineer to train and fine tune a model. So when we looked at it, fine tuning had a much higher barrier of entry for us, but potentially better outcomes. Whereas prompt tuning, much lower barrier of entry, we can move a lot faster. And once you start analyzing it and looking into it, it was actually good enough for the majority of the business cases that we actually came up and the processes we wanted to build out with agents. So with that, we'll actually dive into about three of the agents that we actually built out of Sidekick, kind of the considerations we took in on that, and then how we chose a model to do that particular agent. So one's the exam agent, right? We want to help engineers and clients to be able to quickly learn core concepts in our technology, especially new features or functionality as we release those to the security content agent. So creating correct content rules to be able to actively detect and block malicious activity as threat actors are launching new attacks against companies, but also them parsing, right, of how we can take in a lot of raw telemetry from third-party sources, parse that against our own taxonomy, and then run our own analytics and rule set on top of that. So the exam agent, when we're looking at it, we needed something that could have high token counts because we're going to give it a lot of data, right? We're going to give it PDFs that could be 20 pages, could be 200 pages PDFs, text files or Confluence pages. But this is going to be more ad hoc requests by the user because we're not building exams like constantly. But also we didn't really need a model that had to do a lot of complex reasoning, but context window size was important as well because we need something that could ingest a lot of data. So this is why we chose Nova Lite for this particular task, right? It was extremely fast for most jobs to build out exams. It was about 10 to 30 seconds. For more complex jobs that had those larger PDFs, it was about 2 to 3 minutes to run, but it was extremely cheap and it was smart enough and the context window was large enough for that particular job at hand. Now, when we switch over to security content, it was a little bit different story, right? So within Trellix and most cybersecurity companies, right, the content languages that our products use, they could span, 5 to 10 plus different languages. Trying to find an engineer that could even, write one or two of these languages is a challenge, right? And a lot of these languages are open source. So even within your security operations team, if you go find someone, ask them to write a Sigma Snort and Yara rule, you're probably not going to find one person that can do that, or they may able to do like 25%, maybe even 10% of those different languages. So those are another great opportunity for us to automate an internal task of generating content that would be fed in our products to provide better detection coverage for new emerging threats. And this whole process involved reflection as well. So it allowed the agents to create content, but they were able to reflect on the content they created to actually improve the quality. And so before we had a reflection within this whole workflow, I would say it's about 75% accuracy coming out. Once we added reflection and tools to actually validate the content, we actually saw accuracy shoot up to 99.9% accuracy of the agents. And so this is now hooked up into a data pipeline as all that data I talked about at the beginning that we're consuming on a regular basis, these agents are able to look and sift through that data and identify those anomalies and say, hey, we don't have a coverage for this particular threat or this emerging threat we're seeing. I'm going to go generate content now across the Trellix portfolio and be able to push that into a queue for a human to quickly QA and then deploy out so our customers can take advantage of that much faster. So when we're looking at this one too, like we needed something that was in the middle token range, but the model needed to be able to reflect and take corrective actions on anything that it found or bugs or issues. And the outputs had to be reasonably correct, even though a human would review it before it was deployed, but it had to have a high accuracy of the output because we didn't want to burden users of having to go through and clean up a lot of code that were being put out there. Context window wasn't really a big concern because we're going to provide a lot of data to it, but correctness was probably one of the bigger things, right? And the model needs to be able to look at, tool use. So in this case, this is actually chose Sonnet and Haku for this particular agent as it's running. Now, shifting to the last use case was really around parsing. So within cybersecurity, we're ingesting a lot of data from third-party solutions that could be in multiple different formats. It could be JSON, Leaf, Ceph, CSV, right? And typically in cybersecurity, you have to be able to parse that data to your own taxonomy so you can run your own analytics and rules on top of that. This usually required a human to actually go through all these logs and map each of these fields over to our own taxonomy so our SIM solution can be able to parse this. So this is another great example of how an agent was able to step in and streamline this whole process and remove the human element from a mundane, boring task that no one really liked doing and provide a better customer experience. So now we had this agent. We wanted something that could run in the background. It had to be 100% accurate in the actual output that it actually produced the user. It needed to excel at tool use and complex reasoning. And it had to be 100% correct, right? So in this case, this actually chose Opus because even though it was slower, it was more efficient at this. So this is why, outside of this, right, I would say like as you're going through your process of building agents or determining where you want to plug LLMs into your workflow, like build out your own testing framework that tests all these different models against your specific use cases because it'll definitely help you identify the right products or sorry, the right models to use for your use case at hand. And it also helps you identify like which ones are cheaper and more efficient versus ones that may be more expensive and slower. But I'll also touch on this. So really where things have kind of flipped on their head now too
Hey,
is the model.
Zach.
Yeah.
Zach, we've got about 1 minute left if you can just manage your time.
Cool, cool. Yeah, so I'll just touch on this at last. So I know there's been a lot of talk. So what we started doing now is pulling agents and tools to actually make this whole process a lot more efficient. Um, I'll just play this real quick. So what we've done, that's not playing, is it? Yeah. So what we've done is we actually have now MCP servers built out to make things more efficient. So the tool use piece, it makes them easier to connect with the ecosystem. So now we have over about 30 different MCP servers internally that connect to our entire product portfolio. So now our engineers don't have to worry about APIs connecting to one another. They just connect to the point the agent at the Trellix EPO MCP server, and now that agent knows how to interact with EPO or EDR. They don't have to do a lot of integration and plumbing of different APIs. But if y'all have any questions or want to see more about this or ask how we've gone through this whole